Hello, welcome again to Learning Maths Online with Mafeng. In this video, we are going to be answering the question 10, question 11 of the NECO 2024 exams. Now, you can see the question there. Question 10 says we should copy and complete the table 2.1 for the relation y is equal to x squared plus x minus 12. And this is a quadratic equation. So we are to plot the graph, and the scale was actually given there. So you can see the table there. We are to copy and complete the table. So I'm going to take this off and then bring a table here that I've actually made. So you can see that there I have the table here, y equal to x squared plus x minus 12. And then I'm to fill in this table. Now, there are two methods that I actually know of. One of them is this, and for me, it's quite fast, and that's why I usually make use of this method, which is I'm going to create a table like this, and it is very easy for me to do this. And another reason why I love this method is it conserves space for me, so I wouldn't have to use much space like rough work trying to get the values to fill in here. So what I'm going to do quickly here is I have x here, which are these values. So I'm going to fill in all these values here in this box. So here I'm going to have minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. Now, having done that, I'm going to go back to the equation. I'm actually supposed to get the values of y for all the corresponding values of x. So what I'm going to do here is that I'm going to fill in the terms, or rather the terms that I have on the right hand side of this equation. The first that I have here is x squared. So I'm going to have x squared here. And then the next that I have is this x. So I'm going to have x here. And then the next, I'm having minus 12. Now, for students who usually use this method, some of them usually ignore this minus. So it's very important for you to take this. So I'm having this minus here, minus 12. Now, if you have a negative sign in front of any of the terms that we have there, it is advisable you pick it all together with the sign. Here we have plus x. Now, it doesn't really affect this value. So I can as well put the plus there if I wish, right? So now, and then finally, since I have x squared here, I have plus x here, and then I have minus 12 here, then I'm going to have my y down here. So what I'm going to do is I'm going to get the corresponding values for each of these, even as the values of x are actually changing. So this is the values of x. The value of x here is minus 4. So here it says x squared. That is to say, what I'm going to have is minus 4 all squared. And minus 4 all squared, that gives 16. So this is 16. Again here, says x squared. So when x is 3, that becomes minus 3 all squared. Minus 3 all squared, that gives 9. So I'm going to have 9 here. And it goes on for this also. Minus 2 all squared, that gives me 4. Minus 1 all squared, 1. 0 square, 0. 1 square, 1. 2 square, 4. 3 square, 9. And 4 square, 16. The next, I'm going to pick this up. This is just x plus x. So whatever the value of x is here, I'm going to have this. So when x is minus 4, of course you can say plus into minus 4. That's to say plus into minus 4, which of course we know plus that's minus, and that will still give you minus 4. So it means I'm going to have minus 4 here. Now here is the value of x. When x is minus 3, here is just having x. No coefficient affecting the value. No sign. No opposite sign affecting it. That is to say, we have plus here. Plus does not really affect this. So this will still be minus 3. And then here, minus 2. Here, minus 1. That's because the value of x here, we have just x here. So this will be 0. This will be 1, this will be 2, this will be 3, and this will be 4. Now here we have minus 12. So you can see that minus 12 don't have any unknown here. That's to say x now, which will change the entire value even as we progress when the values of x is changing. So automatically that means here this will be minus 12. For the value for x to be minus 4, this will still be minus 12. For x to be minus 3, this will still be minus 12. And it goes on that way. Minus 12, minus 12, minus 12, minus 12, minus 12, continuously till we get to the end. Now, after doing this, then we are going to put this all together. That is, we can add, we can see that, considering the sign 2 in front of it. So we're going to add starting from here because you can see the equation says x squared plus x minus 12. So we'll take it up from here. 16 minus 4, that gives 12. 12 minus 12, that gives 0. 9 minus 3, that's 6. 6 minus 12, that gives minus 6. 4 minus 2, that gives 2. 2 minus 12, that gives minus 10. And we have 1 minus 1, that's 0. Take note of where I'm taking this from. That's x squared here. 1 minus 1, that's 0. 0 minus 12, that gives minus 12. I have 0 plus 0, that's 0. 0 minus 12, that gives minus 12. 1 plus 1, that's 2. 2 minus 12, that gives minus 10. 4 plus 2, that's 6. 6 minus 12, that gives minus 6. 9 plus 3, that's 12. 12 minus 12, that gives 0. And 16 plus 4, that gives 20. 20 minus 12, that gives 8. Now you can see that this is the table we got from the question, and you can see that they actually fill in some of the values of x. So I can compare that with mine to ensure that I'm on track. So you can see when x is minus 4, I have y to be 0. You can see here minus 4 and 0 here. For x to be 0, y will be minus 12. So you can see x is 0, y is minus 12. Here x is 3 and y is 0. X is 3 and y is 0. Here x is 4 and y is 8. You can see x is 4 and y is 8. So that's just to help me check and to ensure that I did not make any mistake anywhere. But you have to do this carefully. So I'm going to fill in this value here. That's to say the values of y here. So I'm going to have, this will be minus 6, minus 10, minus 12, and I have minus 12 here already, minus 10, minus 6, and then I have 0 and 8. So I filled in the table. Actually, you expected to do this on your question paper. So having done that, I'm going to go quickly to the graph sheet. Now, going to the graph sheet, there's something that you need to know. I'm having two axes, which is the x-axis and the y-axis. Now, to plot the x-axis, I will need to look at the y values. And again, to plot the y-axis, I will have to look at the x values. This is what I'm trying to say. This will help you know exactly where to draw the axis. So let's start with the y-axis. So I want to draw the y-axis. So I have to look at the x values. Now, when you see the x values, you can see here we have minus 4, and then here we have 4. So that simply means that I can draw the y-axis at the middle because it is expected that the y-axis actually follows through the path 0 here. So you can see that once I draw it at this point here, it gives equal space both on the right and on the left. Now on the right hand of the y-axis are the positive values of x. And on the left side of the y-axis are the negative values of x. So you can see it is evenly distributed. So now going to the graph, so you can see I actually drew the y-axis just exactly at the middle. I actually drew the y-axis exactly at the middle to give equal space to the x values, the positive x values on the right, as well as the negative x values on the left. Then again, to draw the x-axis, I have to also look at the y values. So going back again to the table, so you can see, I want to draw the x-axis. So I have to take a look at the y values. So you can see that what I have here is 0, -6, and so on. So I can see -12 happen to be on the extreme of my left. So I'm having y values to go this way, -12 less than or equal to y less than or equal to. Now, the biggest I have here is 8. So you can see this is 8. So what am I simply trying to say? That the y-axis span between -12 and 8 based on the values that we're given for the values of x. So you can see, so that simply means that when I'm going to draw the x-axis rather, now I have to be very careful to give space to the negative values. Now, if I draw it towards the top here, that means I am giving a very good space to negative values of y. If I bring it down here, it means I am giving a very good space to the positive values of y. So you can see here, since I have the values of y spanning -12 to 8, so that simply means at least I should give a little good space to the negative value. So that simply means I'm not going to draw it at the middle, rather I'm going to take it a little bit to the top just to accommodate the negative values. Now, it might not make much sense on this particular graph, but there are also other quadratic graphs that this make a lot of sense, so that you won't have to draw the axis and then discover that while imputing the scale, you now see that you actually gave little space to maybe, let's say, any of the values of the axis. So here I have this drawn already. Now the scale says that 2 centimeter, you can see that it says 2 centimeter to 1 unit on the x-axis and 2 centimeter to 5 units on the y-axis. Now you have to understand the graph. On this graph sheet, each box here from here to here, that is 1 centimeter. So it means if I take 2 of this, that becomes 2 centimeter. So it says 2 centimeter to 1 unit on the x-axis. So you can see from here to this point, that's 2 centimeter. That's 1 unit. From here to this point, that's another 2 centimeter. It means I'm to add 1 to this, it becomes 2. From here to here, that's another 2 centimeter. I'm to add 1 to this, it becomes 3, and so on. And I have 4 here. And then, of course, don't forget, I actually label my axis. This is the x-axis. And of course, this is the y-axis, as you can see here. Now, this is for the positive values of x. For the negative values of x, you can see from here to here, that's 2 centimeter. Remember I said each of the boxes from here to here is 1, and here that makes up 2. So from here to here is 2 centimeter, and that will be -1 to accommodate the negative values. From here to here, that's another 2 centimeter, and I'm going to have -2, and it goes on that way. Then on the y-axis, the scale says 2 centimeter to 5 units. Now, on the y-axis, from here to here, that's 2 centimeter, and that will be 5. From here to here, that's another 2 centimeter, and that will be 10. Here on the negative part of y, that's from here to here, that's 2 centimeter, that will be -5. From here to here, that will be another -5, which makes up -10. So here you can have from here to here is -5, here to here, that gives you -10, and it goes on just like a pattern that way. So you can see that that's -10, and this is -15. Now, don't forget, we have that the values of x are spanning -12 to 8, and then the values of the values of y are spanning -12 to 8, while the values of x are spanning -4 to 4. Now we are going to impute the points that we have. So it says that when x is -4, y is 0. So you can have this here. When x is -4, y is 0. So to have that, I'm going to go over here and say, okay, when x is -4, this is -4, y is 0. Now, on this x-axis, entirely the values of y is 0 because here we have 0 here, right? So this is exactly the point here. I'm going to use a dot here to represent that. Now, it goes on to say, when x is minus 3, y is minus 6. So I'm going to have that when x is minus 3, y is minus 6. Now, to move on again, it is very important for you to know, since we have that from here to here is 1 centimeter, and we have 5 smaller boxes there. From here to here, that's another 1 centimeter. We have another 5, so that makes up 10. From here to here, that gives us 10 boxes. Now, I usually say that it is important for you to know the scale of each of these smaller boxes. Yes, it is very, very important. Now, take a look at it now. From here to here, we have 10 smaller boxes. Here to here, that's 5. If you want to zoom that out, and then you count when you zoom in, you're going to see that. That gives you like 10. So from here to here, that's 5, another 5. That gives you 10. So we have 10 smaller boxes. Now, what is the measurement of each of these 10? Each of these smaller boxes. Since we have 10 smaller boxes, so I'm going to do the math here. That's to say my y-axis now, considering my y, I'm going to say I have 10 smaller boxes. From here to here, I have 10 smaller boxes, and then that's 5 units. So that simply means that I'm going to say that 5 divided by 10, and that gives me, that should be 0.5. Yes, that should be 0.5. So what does that simply mean? It means that each of the smaller boxes is 0.5. So the first smaller box is that 0.5, another one that will give me another 0.5 that makes up 1.0, another one 1.5, another one like that continuously. And I'm going to see myself arriving here at 5. Maybe we could try that. So from here to here, that's 0.5, this is 1, 1.5, that's 2, 2.5, that's 3.0, 3.5, that's 4.0, 4.5, and then finally that gives me 5. So you can see that that's exactly what I'm talking about. Then for the x-axis, I'm having each 2 centimeter gives me 10 boxes. So, and then I'm having 1 unit from here to here, that's 1 unit. So that will be 1 unit divided by the number of boxes, that gives me 0.1. So it means each of these smaller boxes are 0.1. So this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then finally 1. So you can see that that gives me minus 1. So on the negative, as of course, with the minus in front of it, so this will be minus 0.1 down to until I have minus 1. So that's what I'm talking about. So now that will enable me to know how to input this point. So I have x to be minus 3, y to be minus 6. So I'm going to look at minus 3 for x-axis, that's on the x-axis. And then on the y-axis, I'm to locate minus 6, and that means I have to go down here. So you can see this is minus 5, right? And don't forget, I said each of the smaller boxes here are 0.5. So this is minus 5, this is going to be minus 5.5, and then this will be minus 6. So this is exactly where I have my minus 6 with this point there. Then the next I have is minus 2, and then I have 10 here. So when x is minus 2, so we're going to look at that. When x is minus 2, y is minus 10. Because that's quite clear to see that y is minus 10. So you can see that. So here I have x to be minus 10 here with this dot here. And then again, I have y to be minus 1 and x to be minus 1 and y to be minus 12. So when x is minus 1, y is minus 12. Again, this is minus 10, this is minus 10.5, this is minus 11, this is minus 11.5, and this will be minus 12. So this exactly where I'm going to have minus 12. Then when x is 0, y is minus 12. So exactly on this y-axis, x is 0. Entirely, x is 0. So when I have y to be minus 12, and that's to say my minus 12, it's going to be around here. When x is 0, y is minus 12. Exactly what I have. And then again, it goes on continuously. When x is 1, y is minus 10. This is 1, and y will be minus 10. So this is minus 10. And then when x is 2, y is minus 6. When x is 2, I have y to be minus 6. This is minus 5. This is minus 5.5. And this is minus 6. So I have minus 6 around here. Exactly here. When x is 3, y is 0. When x is 3, y is 0. Y is 0 on this x-axis. So this is exactly where I'm going to have the point. And then when x is 4, y is 8. When x is 4, y is 8. I have 5 here. This is 5.5. This is 6. This is 6.5, 7, 7.5, and then 8. As I say, I had to do this because this will help me know how to impute some of these values that might not be captured on the scale. Actually, are not like I had to just follow the scale, but of course we have them in the scale there. We have 8 here, so I have 5, and then I have 10 there. But between 5 and 10, I have 8 there. So now how do I follow this curve? So in my own case, what I usually do, probably you could try that maybe with much practice, you'll be able to follow that. So what I do, I actually use broken lines, follow broken lines. Don't forget again, I'm actually using pen here. And the reason why I'm using pen, and that's because of this video, I just want it to be that clear. But of course, for exam setting, you have to make use of your pencil. So you can see it's a trajectory following itself that way, and so on like that. So now I'm having this broken line, so I decide to just do that to ensure that I'm going to follow it anyway. So maybe with enough practice, you'll be able to do this. But I've been using this for quite a while now. I'm just going to follow it to just a broken line, then light broken line to ensure that. So now, just like the way I did it in primary school, so I'm going to follow up, trace, just like I'm tracing. I don't know if you can still remember how you did it in your elementary school. So you can see it's giving me a perfect shape. Not perfect per se, but at least I'm having something that looks somewhat like a curve. And there it goes. So you can see that. That's quite clear. For some students, they are going to make use of broom, while some are going to make use of the French curve that we have. So you can do that. So I think we're having a perfect shape. Now, for the sake of the exams, I have to label the curve. It's very important to label your curve. You also need to put the axis somewhere. So for me, most times I could just say this is the curve y equal to x squared plus x minus 12. So I have that written somewhere. So we have the curve here. Now the question says, using the same axis, draw the graph of y equal to 2x plus 1. Now this is another graph, but we are to draw it on the same graph and using the same axis. That's exactly what we're going to do. So to have that done, it means I have to create another table. But this time around, I'm not going to make use of all the values of x. And that's because this is a linear graph. So I won't need much of that. So I'm just going to take 3 values, and that will be done randomly. So I'm creating a table for that. You can see that. 3 values. So this is for y equal to 2x plus 1. So now here I have the value of x, and then I can create another just to add that up together. Maybe here you can use substitution. I think that will be fine. You can just go ahead with that. So I'm going to pick the values of x randomly. So you can see that we have minus 4, we have 0. So that's what I'm using. I'm going to pick minus 4, 0, and 4. Or you can try to take minus 3, 0, and 3. I guess I should work with that. So that's minus 3, 0, and 3. And this will be the value of y. So What am I simply trying to say? Now, when x is minus 3, y is going to be 2 into minus 3 plus 1. So that gives 2 times minus 3, that gives minus 6 plus 1, and that is minus 5. So I'm going to have minus 5 here. Again, when x is equal to 0, that's 2 into bracket 0 plus 1. This gives me 2 times 0 is 0 plus 1, and that gives me 1. So this will be 1. And then when x is 3, that's 2 into 3 plus 1. So I'm going to have 6 plus 1, and that gives me 7. So you can see this gives me 7. So this is exactly what I'm going to plot on this same curve or on this same graph sheet using the same scale. Don't forget, you can pick this. You are at liberty to pick any value. I actually picked minus 3, 0, and 3. Someone can take minus 2, 1, and 4, depending on your choice, whatever works for you. But don't forget, just pick 3 values, and that will be enough. So when x is minus 3, y is minus 5. That is on this new curve. That is on this new equation. This new equation that we have, y equal to 2x plus 1. When x is minus 3, y is minus 5. So I'm going to locate minus 3 when x is minus 3. Y is minus 5. So that puts me here. Again, when x is 0, y is 1. When x is 0, x is 0 exactly on this point, y is 1. So 1, I'm going to locate 1, and that's from here to here. Don't forget what I said earlier on, that each of the smaller boxes is 0.5. So here to here is 0.5, and here that makes up 1. So this is exactly where x is 0 on this y-axis here all through. And so y will be 1. And then when x is 3, y is 7. So let's see, when x is 3, y is 7. This is 5. This is 5.5. This is 6, 6.5. And this is, okay, this is 5, 5.5. This is 6, 6.5. This is 7. So this is exactly where I have the value of y being. The value of y is 7 when the value of x is 3. Now, I'm going to use my ruler and draw a straight line. So you can see this straight line. You can see how they align themselves. And there it goes. And that is exactly what I have. So now, because this does not cut this at this point, so I think I can extend this a little and to say this goes this way, so that it's going to cut this at this point and at this point. Now, having done that, that's our graph. And then this one will be y equal to 2x plus 1. That's the graph. That's the graph. That's the linear graph, y equal to 2x plus 1. Okay, now that's quite a long one. So we've been able to plot the graphs for the linear equation that we have here, y equal to 2x plus 1, and then we have for this curve which we're able to generate. Now we're going to look at the next part of the question, which is the D part of the question. And what is it basically saying? It's saying that from your graphs, determine the root of the equation. That's to say x squared minus x minus 13 equal to 0. And we are to do that from the graph. Now, for some students, they are going to say, okay, does it mean I'm to plot another graph or I'm to solve this manually? No, you are not to solve it manually because the question says from your graph. So you can see that specifying where you are to get the root of this particular equation. But I would like you to know that since you are dealing with this graph, most likely this is going to have a relationship with the equations that we are talking about. That's to say, it's going to have a relationship with these two equations. So now, how can I correlate what I have there? Now you can see here, it says that we are to find the root of x squared minus x and then minus 13 equal to 0. We have to find the root of this equation. Now, when we say the root of this equation, that's to say the value of x in which when we impute it into this equation, it actually collapses to 0. So those values of x that collapses the whole of this to 0, we refer to them as roots of the equation. That's ROTS. They are called roots of the quadratic equation. Now, as I said earlier on, don't forget, since they are asking you from the same question, it certainly means that this particular equation we're talking about have a relationship with these equations that we have on this graph. So how can I make it look that way? So I'm going to start from here. Now, take a look at it now. Don't forget, we are dealing with two equations, which are y, I'm going to write it at the top here, y equal to 2x plus 1. And then we also have y, which is equal to x squared. And that will be plus x minus 12. So these are the two equation. So certainly this particular equation will have relation to that. So now how can I make this look this way? Now I would like to have one of this equation on the left, the other one on the right. So I'm going to see that, okay, to be able to achieve this, of course, there are two ways you can do that. But the first thing I'm going to do here is to say, okay, I have x squared here. I'm going to make minus x is going to be the same thing as saying plus x minus 2x, certainly. And then I'm going to have a minus 12 minus 1 equal to 0 that I have here. So you can see that when I simplify this equation, I'm going to have this back. So I'm picking this from here. So you can see that I'm just a bit doing it like you have to, there's a little bit of critical thinking here for you to be able to achieve this. It's just a way of making this equation look like what I have here. And then I'm going to derive something at the end of the day. So now, looking at this now, I'm going to say, okay, move this plus 2x to the other side as well as the minus 1 to the other side. So I'm going to have x squared, and that will be plus x, and minus 12, which will now be equal to, and move this to the other side becomes 2x, and then this to the other side becomes plus 1. So you can see this is what I come up with at the end of the day. So when you correlate it with this particular equations, you will notice that this equation that we're talking about is simply saying that the values of y are equal. Look at it. This is y is equal to 2x plus 1, and I have it here. And then I have y is equal to x squared plus x minus 12. And you can see I'm having it here. So that simply means that, of course, you know, this y is equal to this as well as is equal to this. So what does this tells us about this particular equation? This particular equation is achieved where the two equations that we have are equal. That is to say, the value of y are equal. The value of y are equal. So going back to the graph, now you are going to do that. You are going to see that it is at the point of intersection that we have the two equations to be equal. Now, at this particular point, you can see the two graphs intersecting at this point and as well as this point. Now, the value of y at this point are the same for both equations. So I'm going to trace and then to find out what the value of y is. I'm going to trace that like that. That way, you can trace that. Now, it's very important you show that. So we are going to trace that way, like that, and I have this here. Now, what will be the value of y here? And as well as I'm going to also trace that here, looking at this point here. So you can use a ruler to do that, but I'm going to follow that gradually to say that, okay, this at this point, so this is my value of y here. Looking at it from here, when I take it up to this point. So here, at this point, what is the value of y that I have here? Remember what I said, each of these boxes are actually 0.5 that we have here. So this is 5, this is 5.5, this is 6, this is 6.5, this is 7, 7.5, this is 8, this is 8.5, this is 9, and this is 9.5. So I'm going to say one of the roots of this equation, what I achieve here is that y is equal to 9.5. But of course, I would like you to know that that is not actually the root at the moment. So now we're also going to find this now to say that, okay, at this point here, we can see that this is 5 and this is 5.5. So now what does that simply mean? It means y is equal to 9.5, and also we have y to be equal to 5.5. Now these are the values of y. Then what will be the corresponding values of x? Because remember, we are looking for the root of this equation. So I'm going to take it this way, probably to say, how about we find the, what do you call it now? That is the coordinate at this point. The coordinate at this point, we have y to be equal to this. Then what will be the corresponding value of x? Let me see that. Remember, on the x-axis, each of the boxes, the smaller boxes, are 0.1. So if this is 4, this is going to be 4.1. So I have here, I'm going to write it a bit clear here. That's to say x, comma, that would be 4.1, comma, 9.5. And that is what I have there. 4.1, comma, 9.5. I have that there. Then again, here also, remember the value of y is 5.5. So I'm going to trace up to get the corresponding values of x. Now you can see this is minus 3 and this will be minus 3.1. So the coordinate I have here, so I'm going to write that clearly here. I have minus 3.1 as well as 5.5. Okay, I hope that's quite clear. Minus 3.1, comma 5.5. So now to achieve this particular result that we have here, that is to say, what will be the roots of this equation? That's the corresponding values of x here, since we're able to show that this equation can generate to give us this. And at this particular point, we can say that the values of y are actually equal now, right? So now what I did was, and I said, okay, the coordinates, as I said, let me see, repeat that again. Remember, this will be x, comma, y. I have that here, x, comma, y. And I have what I have here, that's 4.1, comma, 9.5. That's the first one. And then I say, or 3, that's minus 3.1, comma, 5.5. Minus 3.1, comma, 5.5. So now, what are the roots of this equation? At this particular point of x, the whole of this will become 0. As well as at this particular point, when x takes this value, minus 3.1, the whole of this will become 0. Certainly, if you are to check that up, you are going to see that it is going to work. What am I simply trying to say? Now, when we impute 4.1 in this equation, what we are going to get approximately is going to be 9.5 for this equation, as well as when we impute it here, we're also going to have, what do you call it now? We are going to have 9.5. So that is just what this is trying to say. I hope you're able to understand that if I put the value of y when x is equal to 4.1 in this first equation, I'm going to have 9.5. When I put it in here, I'm also going to have 9.5. And then when I put x to be equal to minus 3.1, in this equation, I'm going to have 5.5. Here, that's the value of y is going to be 5.5. When I do the same for this, I'm also going to have 5.5. So invariably, this is telling us that for this particular equation, the roots of this equation are going to be the corresponding values of x. That is to say, root of x squared minus x minus 13 equal to 0 are, that is x equal to 4.1 or x is equal to minus 3.1. Now, this is just a bit kind of logical for you to think it this way, but that is actually true. So we can say that we got it exactly from the graph. You can show it on the graph, or you can as well show it on your answer booklet. Of course, this graph is going to be part of your answer booklet. So that is what we have. So that being said, we're going to move to the next, which says that find the minimum value of y from the quadratic graph. Find the minimum value. Look at it. We have to find the minimum value of y from the quadratic graph. Now, take a look at it. This says minimum value. Of course, there might be some questions that will say minimum point. Now, when it says minimum point, of course, it means it is asking you to find the coordinates. That is to say the x and the y values. But when it says the minimum value of y, so it means it is specific. saying the minimum value. Of course, we know that the minimum value is going to be somewhere around here. That's the minimum value. If we say maximum value, you say that maybe for a curve that is this way. But since this curve goes this way, of course, the minimum value of y. Now, looking at this, we are going to trace from the base of this curve. We'll trace. Now, this is an approximate value you get. So, of course, there's a range of that your value need to fall for correct answers. Your answer must fall within that particular range for you to be awarded the mark. But so you can see here. So at this point, I'm going to trace it to this point here. This is the minimum point here for this particular curve. So I'm going to check what is the value of y. Now this is 10. Don't forget each of the boxes are 0.5. So this is 10.5, this is 11, this is 11.5, and this is 12. And then finally, this is 12.5. So I'm going to say minimum value of y is 12.5. And the minimum value of y is 12.5. So now that marks the end of this particular question. I believe it does really make sense, but of course it involves a lot of little critical thinking, most especially for this other part of this equation that we have. So don't forget to subscribe to my YouTube channel, and you can as well share also with others to be able to have a better understanding of this. Thank you.